In this lesson, we learn about spanning tree protocol concepts and features. Spanning tree protocol uses bridge ID to identify a switch. Bridge ID is 8 byte long and contains two parts. The first one is a bridge priority and the second one is a MAC address. The MAC address is 6 byte long and unique among all switches. It is not configurable. The bridge priority is 2 byte long and broken down into two fields, the priority and the extended system ID. The priority allows to configure the bridge priority. The extended system ID allows to create multiple STP instances. Now let's look into the detail of the bridge priority. The priority field makes up the 4 leftmost bits and is value of 0 to 61,440. Bridge priority field can only be set in the increments of 4096. The extended system ID is 12-bit long and has a value of 1 to 4095, corresponding to the respective VLAN participating in STP. The default value of the priority is 32,768. The default value of the extended system ID is 1. Cisco per VLAN spanning tree plus adds the extended system ID to the bridge priority, which makes the default value of the priority is 32,769. When comparing bridge IDs of two switches, if the bridge priority is tied, then the MAC address is used to determine which switch has better bridge ID. STP uses Bridge Protocol Data Unit or ppdu to allow the switches to communicate with each other to build spanning tree. ppdu contains the following fields. Root identifier. This field lists the root switch information. Root path cost is the cost from the current switch to the root switch. The root switch has the root path cost of 0. So in this example, the root path cost from the current switch to the root switch is 4. Bridge identifier. This field lists the information of the current switch that forwards the ppdu. Port identifier. This field lists the ID of the port that forwards the ppdu. Timers. All switches use the timers set on the root switch to decide their actions. The next concept in spanning tree protocol is the root bridge or the root of a spanning tree. Root bridge is the switch that has the lowest bridge ID. In this network diagram, IT Life Skill Switch 2 has the lowest bridge priority, which means it has the lowest bridge ID. Therefore, it is a root bridge. STP also uses the concept root path cost to build the spanning tree. Root path cost is the sum of all port costs from a non-root switch to the root switch. Default port cost is set by the media speed and it is given in this table. Please note that port cost is configurable. Root bridge always have the root path cost of 0. Assuming all switches in this network diagram use default port cost, from the table we can figure out the port cost of all the ports on IT Life Skill Switch 3 and IT Life Skill Switch 1 are 4 because they use 1 gigabit per second links. Now let's calculate the root path cost on the port GIS12 on IT Life Skill Switch 1 and on the port GIS31 on IT Applied Skill Switch 3. In this network, IT Applied Skill Switch 2 is a root switch, so it advertises its root cost of 0 to switch 1. Switch 1 receives the ppdu with the root cost of 0 on the port GIS12, so it calculates its root path cost by adding its port cost of 4 to the root cost of 0, make its root path cost is 4. IT Life Skill Switch 1 then advertise its ppdu with the root path cost of 4 to Switch 3. Switch 3 receives the ppdu with the root cost of 4 on the port GIS31, so it calculates its root path cost by adding its port cost of 4 to the root cost of 4, make its root path cost of 8. Let's move on to STP port rows and their status. The first port row is the designated port rows. Designated port is a port that forwards superior ppdus. Designated port is in forwarding state. All ports on the root switch are designated ports. In this network diagram, all ports on IT Applied Skill Switch 2 are designated ports because it is a root switch. Port 31 on Switch 3 is also a designated port because it forwards superior ppdus. The next port row is the root port row. Root port is a port on a non-root switch that receives superior ppdus and has the lowest path cost to the root switch. There is only one root port on a non-root switch. Root port is in forwarding state. In this network diagram, the port GIS32 on IT Applied Skill Switch 3 is a root port. Also, the port GIS12 on IT Applied Skill Switch 1 is a root port. The next port row is non-designated port rows. Non-designated port is a port on a non-root switch that receives superior ppdus and has higher root cost than the root port. Non-designated port only listens and processes ppdus to set its state to blocking. In this network diagram, the port GIS13 on IT Applied Skill Switch 1 is a non-designated port. The last STP port row is the disable port row. Disable port is a port that is shut down by a network engineer. Disable port is in disable state and it does not process ppdus. STP also maintains two intermediate port states to allow a non-designated port to transition from blocking state to forwarding state safely. For example, if there is an issue happens to the link between IT Applied Skill Switch 2 and IT Applied Skill Switch 1, thus cause Switch 1 stop receiving ppdus from Switch 2. Switch 1 will perform STP recalculation and transition its port GIS13 from blocking state to listening state. At listening state, the port GIS13 only listens for ppdus to get it ready to transition to learning state. At learning state, Switch 1 learns MAC addresses received on port GIS13 to get it ready to transition to forwarding state, and here is the entire transition process. Let's move on to an STP feature, which is Ether channel. Ether channel combines up to 8 equal bit links between the same pair of switches into an Ether channel. In terms of STP, switches treat the Ether channel as a single interface. Here is how we can configure Ether channel in this network. For example, if one of the links in this Ether channel fails, but the other link is up, STP conversions does not have to occur. Podfast is another feature that allows a port to immediately transition from blocking to forwarding, bypassing listening and learning steps. Podfast must be enabled on a port connected to a host. So in this network, only these ports should be enabled with Podfast. Cisco ppdu guards is a feature used to protect a spanning tree from unexpected change. It should be enabled on ports connected to hosts. When enabled on a port, Cisco ppdu guards will disable the port if any ppdus are received on the port. In this network, only these ports should be enabled with Cisco ppdu guards. Now, if someone removes the cable connected to this computer and connect it to a switch, the switch now starts sending ppdu to IT Life Skill Switch 4. By then, ppdu guards kicks in to disable the port to protect the spanning tree. Please read the keynotes for this lesson. This is the end of this lesson. If you have any questions, please put it in the comment section below. We will get back to you as soon as possible. Thank you very much for watching.